Hey, part two. Might be a little bit more difficult, but I have faith. I think you can handle it. Let's see. Part two. Let's go. Lesson 4. Ooh, look at this. Doesn't this look fun? Okay, write the problem very neatly. We have variables on both sides, so we're going to get rid of one of the terms that has a variable. So I am going to draw my line down, and I'm going to find my terms. All right, let's go. So on this side I have 2 terms. On this side I have 2 terms. All right, and I'm going to get rid of one of my variable terms first. If I see a negative term, like that negative 1/6 x, I like to add those. I like to get rid of those by addition. I don't know, I just prefer addition over subtraction. So I'm going to add 1/6 x, canceling the minus 1/6 x out. I'm going to take that to the other side because my property of equality says I have to do what I do to one side, I have to do the other side. And excuse me, I'm left with a 9 over here. And I can bring my -1 down, but I'm wondering what this is going to equal. 2/3 x plus 1/6. Well, simple. I'm just going to do 2/3 plus 1/6. 2/3 plus 1/6. I need common denominators when I'm adding or subtracting fractions. So I'm going to find the common denominator of 6. So I have to multiply the top and bottom of the 2/3 by 2 and get 4/6 and 1/6. And then I, excuse me, I add those and I get 5/6. Okay, so now I'm ready to input that here. I have 5/6x. Not too bad, right? You just have to make sure you take your time, go off to the side, and do the work. Adding and subtracting of fractions. Now I'm left with a 2-step equation. All right, again, it all comes down to our terms here. We have that term and that term on the left side of the equation. And so what are we going to do? We're going to get rid of the non-variable term first. Cancels. What am I left with? I'm left with a new equation. Every time I cancel something out, I'm left with a new equation. My new equation is 5/6x equals 10. Still balanced. Still balanced because we've done the same thing to both sides. We've used properties of equality. All right, now we have a coefficient, the number in front of the variable, right? Number next to the variable. It's being multiplied by the variable. That is a fraction. That coefficient is a fraction. So to get rid of that, we can multiply by the reciprocal. A number times its reciprocal always equals 1. So we get 1x left over, but I'm not going to write the 1 because it's just assumed that it's there. All right, now 10 times 6/5. Well, when I multiply fractions, I got to make sure any mixed numbers or whole numbers are written as fractions, so I put a 1 underneath there. And now I can cross simplify. Common factor of 5 and 10 is 5. 5 goes into 5 once. 5 goes into 10 twice. And in the numerator, I have 12. Denominator, I have 1. So my answer is just simply x equals 12. All right. Not too bad, right? The big issue is we have fractions. And so you just got to go over into some scratch workspace and do the math. All right, now I'm going to choose to just do f for the sake of time. All right, I'm going to just use the way it's written right there to save myself some time and space of recopying it. Do I have variables on both sides? Yes, I do. I have the c there and the c there. So our first step is to get rid of one of those terms that contains the c, the whole term. All right. If I take the time to just outline my terms, I got a negative 5/4 C, and I have a minus 1/2. Over on the right side of the equation, I have a negative 3/4 and a plus 5/8 C. Now, I want to get rid of one of these variable terms here. So I like to get rid of the negative one. So I'm going to add 5/4 C and add 5/4 C. So that cancels out. I'm left with negative 1/2 equals negative 3/4. But what do I have to do here? I gotta add these guys. So I'm gonna get some scratch space here, right off to the side here. I'm gonna go 5/8 plus 5/4. Need a common denominator. I think my 4 and 8 both go into 8 evenly. I can leave that top one as 5/8. I gotta multiply by 2, that's 10/8. So 5/8 plus 10/8 gives me 15/8. All right, so I'm left with on this side 15/8 C. Now I have a two-step equation. When I have a two-step equation, then I'm simply going to look at my terms over here and get rid of the non-variable term first. Remember, we can get rid of whole terms using addition and subtraction. So this whole term here, I'm going to add 3/4. I'm going to add 3/4. It cancels out there. I'm left with 15/8 C. I don't know what I get over here, so I need some scratch work to get this done. All right, negative 1/2, and I'm going to add to that 3/4. Need my common denominators, which would be 4. This stays, multiplying that by 2 and 2, so that's negative 2/4. Negative 2/4 plus 3/4. So, right, we keep the denominator, and then you think about the numerator. So it would be negative 2 plus 3, right? This guy and this guy, combining those. Negative 2 plus 3 is 1/4. All right, so we get 1/4 as our result. And now we have our final step. We see a variable, and we see it having a coefficient that is a fraction. So we're going to multiply by the reciprocal, 8/15. 8/15. All right, let's see how we do. Cross simplify, because 8 and 4 have a common factor. 4 goes into 4 once, 4 goes into 8 twice. Now we bring down what's left, because we know that reciprocals multiply to equal 1, so we get 1C. We don't need the 1 because it's understood that it's right there in front of that C. And on the other side, we multiply the numerators and get 2, multiply the denominators and get 15. There we have it, our answer for that long one. Now for our last problem, which is a word problem. Oh no. The big important part here is to summarize this in words. Then we're going to do variable, and then we're going to do our equation. All right, now this lesson is all about variables on both sides of the equation, so this is going to be a little bit more complicated than you're used to. Let's read it. Green's Gym charges a one-time fee of $50 plus $30 per session for a personal trainer. A new fitness center charges a yearly fee of $250 plus $10 for each session with a trainer. For how many sessions is the cost of the two plans the same? Okay, so I see the word the same, so that to me says that it's asking about when are the two plans going to have an equal cost. So that gets us into the problem. It starts to get us the idea of equality. So we could write an equation with this because of that word the same. All right, and What is the same? What do we want it to be the same? The total cost. Well, how do we calculate the total cost of each one? All right, what goes into the total cost of each one? So we want the cost of Green's gym, right? What's the cost of that? It's going to be a fee of $50 plus $30 per session. And we want to see when that is the same as this new gym, which has a fee of $250 plus $10 per session. All right, write all that down. So you have to, what are we comparing? What are we making sure is the same as? We're making sure that the total cost for the gym memberships are the same. When will that happen? How many sessions will that be? All right, so this phrase in the middle, that phrase in the middle there, is the same as, is going to be our equal sign, and that'll be our left side of the equation, that'll be our right side of the equation. All right, what's the variable here? What's the thing that can change for each of them? Well, we see in the question it says for how many sessions, right? How many sessions? So it's asking that. So let's go with S represents the number of sessions. And now it's time for our equation. All right, well, we know that is the same as is equals. Now, for the first, Green's gym, is that what it's called? Green's gym? Yes, it has a fee of $50 plus $30 per session. And there's that word per session, or rate. That typically means multiplication here. And what are we going to multiply the 30 by? Well, however many sessions you take. If you take 2 sessions, it'd be 2 sets of 30, 2 times 30. If you take 30 sessions, it'd be 30 times 30. 10 sessions, it'd be 30 times 10. All right. So we have that fee of $50, and then we're going to add to it $30 per session. Okay, and then for the new gym, it's $250 fee. It just happens one time. We're not multiplying it by anything, and we're going to add to it $10 per session. All right, you see Green's gym, well, it starts off at a much lower fee, with a much lower fee for the year, but then the sessions are pretty expensive. Whereas this new gym is like, yeah, we're going to be expensive, but you don't have to pay as much for the session. So which one's better? Well, the question is, for what number of sessions will this be the same price? And that's what we're going to solve now. There's a variable on both sides, correct? So we're going to get rid of one of those terms with the variable through using addition and subtraction. So we get 250, addition or subtraction, in this case subtraction. We get 50 plus 20s. Now we have just a two-step equation. Now that the variable's only on the left side, we cancel it out of the right side. I'm going to subtract 50, we get 20s equals 200. I'm going to just scribble it over here. 20s equals 200. Now we're going to divide by 20, and we get 10 sessions. So if you went to Green's gym and got 10 sessions, it would cost the same exact amount of money if you went to this new gym and got 10 sessions. Okay? So there you have it. 10 sessions is like the break-even point when both gyms, it wouldn't matter which gym you went to if you wanted to go to 10 sessions. All right, so that is our example for word problems that have variables on both sides. Pretty tricky, but I think you can handle it. Make sure you write out in words what's being compared, what's equal, and that will help you set up your equation.